You know, when you have plus and negative, so there's going to be what? Attraction. So when this attraction occurs, they cancel out and becomes, the net charge is now going to be 0. They become stable. So at 0, they are stable. So now, when the attractive forces in a compound is equal to the repulsive forces, that is when there is an equality between the attractive forces and the repulsive forces, that will give rise to what we know as okay. So over to chemical bonding. Now, when you hear of a bond, it should signal to us that there is a kind of interaction involved, or let's say attraction. Yes, let me just use the literal word, it means attraction. When you hear bond, it means attraction. Now, with reference to chemical, it has to do with what is like bonding in chemistry. Now, bonding in chemistry happens at the molecular, or let's say, molecular level, because it's from this bonding of atoms that we now get our compounds, like that we now form part of the products we see in our everyday life today. So now, without this interaction, there is not going to be stability. So the essence of this interaction is to ensure that the compound that is formed is stable, like to form a stable product. That is the essence of this. And there's also energy involved in this. So first of all, I will define this chemical bonding. It's defined as the attraction between atoms. Chemical bond has to do with the attraction between atoms, leading to formation of compounds or molecules. Because we just have, let's say, this is hydrogen. This is just an atom. But when you have H2, now it's no longer at the atomic level, it is now a molecule, because this is made up of 2 hydrogen. Now, how did it come about in this form? It is because there was an interaction. There is a bond. Something happened between them that led to the hydrogen taking this form, appearing as a molecule. So this is what happens in chemistry. You see that so many compounds are formed. It's all formed through bonding. For instance, let's say HCl, even water, is all due to chemical interaction. Attraction of one of the components to the other component, that is the atom. Interaction between the atoms will lead to these chemical bonds. And remember what I said when I was describing the electronic structure of the atom, that our focus will be on the valence shell, because that is the ones that actually take part in this interaction. The electrons on that valence shell, they are the ones involved in bonding. Now, in bonding, we talk about forces. There are forces involved. We have attractive forces and repulsive forces. Now, the attractive forces are those ones that bring the atoms together. And then we also have repulsive forces. So I'll just write it. We have attractive forces and what? Repulsive forces. Now, these two concepts are very important. In fact, it's an objective question, because during the last set, I came across questions on the students defining these forces. So this attractive forces is the force that is keeping the atoms together, like bringing them together, while the repulsive forces are those ones that are preventing them from coming together. So now, in an atom, let's say I use let me just use hydrogen as an instance. Like I already have here, this is hydrogen atom. Remember, this is the hydrogen atom. You just have 1 electron around this. Why this is another hydrogen atom, you just still have 1 electron. I want to form this molecule. Now, if I'm to represent this by the electronic structure, I'm going to have the nucleus here, then I have this electron here. Then this one, I'm going to have the nucleus, then I'll have this electron here. Now, these two electrons, because they are of the same charge, this is negative charge and this is negative charge, they will repel each other. They will prevent each other from coming close to each other. Why? Because we have a positive charge in this nucleus. There will be more attraction between the electron and the nucleus. That is why it can stay in this shell. Like a kind of, there is a force holding this electron in this shell. It's because of that attraction between this shell and the what? Nucleus. So now, so that is what we're talking about for attractive forces. But for repulsive forces, those forces prevent them. If, for instance, now let me say it's helium I have here, I have two electrons. It's going to prevent, the repulsive force will prevent the coming together of the electrons because they are of the same charge. So I want to re-emphasize that attraction happens in opposite charges. It brings atoms together. It happens in opposite charges, but in repulsion, it occurs when the charges are the same. So this one occurs when we have similar charges. So the atoms tend to be far apart from each other. But this one, the atoms are attracted to each other. So that's the attractive forces are those forces that keeps atoms attracted to each other, and it happens in what? In let's say when the atoms have different charges. So that is where it occurs. Remember, in our basic chemistry and physics, we know that like charges repel each other while the opposite charges attract each other. You know, when you have plus and negative, so there's going to be what? Attraction. So when this attraction occurs, they cancel out and becomes, the net charge is now going to be zero. They become stable. So at zero, they are stable. So now, when the attractive forces in a compound is equal to the repulsive forces, that is when there is an equality between the attractive forces and the repulsive forces, that will give rise to what we know as equilibrium distance. Please note this, it's a very important question. So when this and this are equal, is equal to this, we have what we know as equilibrium distance. I've seen it in many past questions, and your case is not different. You are still going to come across this. So please take note of this. That is when it occurs when the attractive forces is equal to the repulsive forces. Then at equilibrium distance, the net charge is zero. And also there is what? Stability. Remember, when the word equilibrium is at equality, when it is equal, so both positive and negative is the same. So the net charge is zero, and that atom is said to have attained that stable state, or that compound has attained that stable state. So that is what this concept of equilibrium distance is talking about. So now let's go over to the chemical bond.
Hello everyone, I trust you found this lesson from Academy X helpful and insightful. This is just a glimpse of what we're prepared for you. Inside the full Academy X course, you get access to every lecture, solved examples, quizzes, and study resources you need to excel in this subject. To unlock a complete learning experience, simply click the link in the description below. Join us at Academy X, where we bridge the gap between knowing and truly understanding. See you inside the full course.